How a push-button station works. In most industrial machines where motors are used, especially high-power motors, a push-button station is used in order to start and stop the motor. The first button starts the motor. The second button stops it. Most industrial motors are of the three-phase type. That is, they are connected with 3 wires to the power line, and it is necessary to connect or disconnect the 3 wires at the same time in order to start or stop the motor. This is a typical industrial motor with its 3 connecting cables, as well as the corresponding schematic diagram. To connect and disconnect the 3 cables, a device called contactor is used, which is activated by means of a coil which moves the 3 contacts. The contactor has a fourth contact of a smaller current carrying capacity, which is called auxiliary, and it plays an important role in the operation of the push-button station. As you can see, the motor is connected to the 3 main contacts, and when the coil receives a suitable voltage, usually 110 volts, it becomes magnetized and pulls both the main and auxiliary contacts together. So far, we have a way to turn the motor on and off just by applying 110 volts to a small coil. We will now see how the push-button station simplifies the operation of a machine and provides greater safety whenever it is needed to disconnect the motor in an emergency, in addition to its normal functions. Let's look at the push-button station in a schematic. The start button is a normally open momentary switch, which means that it allows current flow when it is being pressed. When released, the current will stop. The stop button is a normally closed momentary switch. This means that it allows current flow when not being pressed. That is, when the button is released, current may flow. When it is pressed, current flow stops. Next, let's see how these 2 buttons work together with the auxiliary contact of the contactor to allow turning the motor on and off. In the machine, there is a transformer to provide the 110 volts in order to activate the coil of the contactor whenever necessary. The machine's supply voltage, typically 220 or 440 volts, enters the transformer and is stepped down to 110 volts to operate the contactor coil and other control circuits when present. The output of the transformer, 110 volts, consists of 2 cables. One of them will be called neutral and the other one live. It is very common for the neutral wire to be connected to the metal frame of the machine. For our explanation, the neutral wire will only go to one end of the contactor coil. The live cable goes to one terminal of the stop button. The other terminal of this button is connected to one terminal of the start button. The other terminal of the start button is connected to the free end of the contactor coil. Now our circuit will be as shown. Since the machine is connected to the main power line, the transformer will deliver 110 volts through its output cables. The neutral wire will be connected to one end of the contactor coil. The live cable will be connected to one terminal of the stop button. Since the stop button allows the current to go through it when not pressed, the 110 volts will go through its contacts to one terminal of the start button. This way, you only had to press the start button for the contactor coil to receive 110 volts. Its main contacts close and the motor starts to rotate. Unfortunately, as soon as we release the start button, the 110 volts will be interrupted to the contactor coil and the motor will stop again. This is where the contactor auxiliary contact comes into action. All it takes is to connect the auxiliary contact in parallel with the start button to solve this problem. If we now press the start button, the contactor coil will be energized. However, when you release the start button, the auxiliary contact will act as a jumper across the start button terminals, so current keeps flowing and the motor stays on. If we want to turn the motor off, we will simply press the stop button. The current will be interrupted and the motor will stop. When the stop button is released, the motor will not restart because the auxiliary contact is now open, and in order to restart the motor, the start button must be pressed again. This system has a high flexibility, since you can install several stop buttons in various points of the machine, especially if it's a large machine, wired in series with the original stop button, so an operator can turn the machine off no matter where he or she is standing around the machine. Switches can also be placed on the safety guards, so that when opening a guard, the motor will stop. An emergency stop switch, also connected in series with the original stop button, can be used to stop the machine in case of an emergency. I hope this video has been useful to you. Thanks for watching and please subscribe to my channel.